I'm Rochelle Lim.
I'm Janine San Pedro.
I'm Fritz Tariana, and today we're going to talk about wave. Well, what is a wave?
Well, Fritz, wave transports energy through a medium and then it propagates with a specific speed that depends on the property of the medium.
Oh, what are the different types of waves?
So there are two types of waves, Fritz. There is a mechanical wave and an electromagnetic wave. So a mechanical wave has three kinds of waves: transverse waves and the longitudinal waves.
I see.
Mechanical wave travels through a medium, which means it requires a medium for it to occur. So one type of mechanical wave is a transverse wave. Transverse wave is the displacement of the particles in the medium, which are perpendicular to the direction of the waves, which means that the particles move up and down while the wave goes to the right. Another type of mechanical wave is a longitudinal wave, which is a displacement of the particles in the medium, which are parallel to the direction of the wave. So here the particles oscillate back and forth. Examples of waves on a string. The first one is the string attached to a curtain.
The second one is the jump rope.
Another example for the waves on a string is that on the guitar.
So a sound wave is a type under the longitudinal wave. There are two types under this. Infrasound, the frequency of it is below normal human range of hearing, which is 20 Hz to 200 Hz. And ultrasound, the frequency is above normal human range of hearing, 20 kHz and to 200 kHz. The normal range of hearing for human is 200 Hz to 20 kHz.
Examples of sound waves would be the waves emitted by the wind chime, speakers, the guitar, and the piano.
In sound waves, they exhibit Doppler effect. So Doppler effect is the shift in frequency and wavelength of waves. So this is the equation. F prime is equal to V plus VL over V minus Vs times frequency. So F prime is the new frequency, V is the speed, which is fixed to 343 meters per second. VL is the speed of the listener, and Vs is the speed of the source, while F is the original frequency. So frequency is positive if the listener moves towards the source, and negative if the listener travels away from the source. Meaning, if it is positive, there is an increase in frequency, and if it is negative, there is a decrease in frequency.
An example of a Doppler effect is exhibited by the electric wave. Periodic waves, propagating disturbance in a medium due to periodic excitation. So periodic waves are repetitive. An example of a periodic wave is this illustration. So this is what we call the crest, which is the upward displacement of the wave, while the throw, this one, is the downward displacement of the wave. The maximum displacement that the wave could reach would be what we call the amplitude. A wavelength is a two successive crests or two successive throws.
These are the equations for waves. V, which is the speed, is equal to wavelength times frequency. Frequency is equal to 1 over period with the unit of hertz. Another equation is y is equal to amplitude sine wave number x plus minus angular frequency times time. Wave number is equal to 2 pi over wavelength. Angular frequency is equal to 2 pi over period, or 2 pi times frequency. So if the wave is going to the left, the sign is positive. If the wave is going to the right, the sign is negative. For a transverse wave, the equation is V is equal to square root of tension over linear mass density. And for a longitudinal wave, for fluids, V is equal to square root of bulk modulus over density. And for solid, V is equal to the square root of Young's modulus over the density.
Electromagnetic waves can propagate without a medium. So an electric wave and a magnetic wave are perpendicular to each other. So these are the types of electromagnetic waves. The first one is the radio waves. Radio waves can propagate in the ionosphere. Next is the microwave. The microwave is used for communication since it can easily pass through the atmosphere of the Earth. Next is the infrared. The infrared can be observed, it can exhibit heat. Next is a visible light. Visible light is light that can be seen. Ultraviolet can be absorbed by the skin, so it can cause cancerous cells or kill cells. Next is the X-ray. X-ray can be absorbed by dense objects. And lastly, gamma rays. Gamma rays can be used for sterilizing objects. So the radio waves, being the first one, it has the longest wavelength at the lowest frequency. While the gamma rays exhibit the shortest wavelength and the highest frequency.
Example of a radio wave is the television.
Waves emitted by the radio. Another example of microwaves is that on the microwave oven.
Wave emitted by phones.
Example of infrared rays is that of the remote controls.
The second example is the heat.
The heat is the one that is released by humans.
Examples of visible light waves are the waves emitted by the flashlight and the waves emitted by the light bulb.
First example of ultraviolet is the sun. And the second example is the fluorescent lamp.